Without further ado, let me officially welcome everyone to the IMARC Metz Arena Live episode for September. We've been holding this for the last few months. This is the fourth episode that we are running. We've gone all the way from exploration now, and we are in the project evaluations topic. The Mining Plus team, Colin and McVie, has done a great job in sort of ensuring that our episodes link in some way or otherwise tell the story across that mining supply chain. The Metz Arena is part of, obviously, IMARC and the IMARC Online event that's happening later this year in November. There will be some episodes of the Metz Arena within the IMARC Online event, which unfortunately is taking place, or otherwise fortunately, on that digital platform. The whole purpose of the IMARC Metz Arena is to connect miners and Metz together. Each episode we have a guest miner or otherwise, a guest speaker to talk about a particular problem statement. And then between Mining Plus, who is the technical sponsor and supporter of the series, as well as the Victorian government, they select 5 to 6 companies to take part in each episode. So for today's episode, we have Whittle Consulting, Optika Solutions, REMPLAN, Deswik, Dassault Systèmes, and also Ausenco joining us. Each of them will have a few minutes to talk about their particular solution and how it helps with the EMR capital problem. And then we'll also have Q&A between Colin and some of these speakers, as well as the audience as well. I don't want to take up too much of this time because I will hand over to John Chomley, who is our guest speaker from EMR Capital. John is their investment director and sort of works in that twofold of both being a miner and an investor. John, over to you.
Very good, and thanks, Sherene. So my name's John Chomley. I'm an investment director at EMR Capital. And on behalf of EMR Capital, it gives me great pleasure to pose the problem statement in this 4th episode of the IMARC Metz Arena Live. I'd like to take this opportunity to thank IMARC for hosting this event and their supporting partners, the Victorian Government and Mining Plus. Firstly, a quick background to EMR Capital. We're a specialist resources private equity manager with extensive mining operational and investment experience. We currently own and operate 9 mining operations and projects in 6 countries globally across 4 core commodities, being gold, copper, coking coal and potash. This portfolio includes 5 current producing mines, so that 4 of those being in Australia, the EMR Golden Grove Basin Precious Metals Mine, in WA, in Queensland, Capricorn Copper Mine, the Kestrel Coking Coal Mine and Ravenswood Gold Mine, and in Zambia on the copper belt, the Labambe Copper Mine. We've put this portfolio of operating assets together over the last 5 years. In such a competitive space as mining investment, EMR Capital is always searching for innovative methods and tools to evaluate and optimise both the operation of our current portfolio and the next generation of investments for EMR Capital. So pointing to today's problem statement, I'd like to focus the topic on the opportunity to rapidly evaluate and optimise aspects of mining projects during the acquisition process. Mining assets are often come to market via a sale process run by investment banks, which generally involve 2 phases. Phase 1, where limited information is provided on the project or mine. Usually that's a financial model and an investment memorandum. And you have about 4 weeks upon which to submit a non-binding indicative offer at the end of this period. The lack of detailed information in this phase makes it difficult to conduct detailed optimisation work. So our focus is to shape the investment case and identify the key drivers of value based on the information provided, which will largely provide the focus for phase 2 of the sale process. Assuming we're invited to phase 2, we're provided with access to detailed data room, which generally will include things like drill hole databases, block models, detailed mine and life of mine plans, feasibility studies and month reports. Stage 2 will generally last about 6 to 8 weeks prior to the requirement to submit binding bids. In this phase, EMR Capital targets is to establish a mine plan with detailed mining inventory, operating and capital cost profile. Obviously, the challenge in such a short time frame is to identify the opportunities to create value. At EMR, we take an approach of what could this mine be in 3 to 5 years' time, more than just focused on what it is right now. And look at how can value be further enhanced by pulling the right levers, which may include operational improvements, expansion, increasing volume, increasing grade, or life of mine extensions. These factors are key to supporting a competitive bid, and it's that ability to rapidly gain a solid understanding and substantiate the upside potential and the risks associated with delivering it, whilst at the same time identifying and assessing downside risks, such as increasing capital requirements or future environmental liabilities. I would like to put forward 2 opportunities that EMR has identified. You know, we've obviously gone through quite a few of these sale processes, and these are things that would greatly assist us to optimise that phase 2 of the sale process, helping us form a broader view on an asset's potential or pitfalls. The first of these is a tool to enable the rapid, and when we say rapid, that's sort of within 4 weeks, so that we're not pushing it right to the end of that second phase, to analyse how a mine's value is impacted by variation or varying the cut-off grade. And that's for both for underground mines and open pit operations, and to do this in a cost-effective manner. The second, I suppose, part of this question is, once again, tools or the ability to identify the rehabilitation costs associated with the mine's development, to provide for a range in closure standards to help predict potential changes in key stakeholder expectations over time. As we often see, this is a constantly moving status. The ability to carry out these types of analysis would enhance our ability to value projects and tailor our final bids to suit, which ultimately leads to an increase in the chance of our success in winning assets. Thanks, Sherene.
Thanks for that, John. Colin, do you have any particular questions that you wanted to throw at John at this point, or?
No, I think it'd be great to hear the companies we've got, how they respond to that opportunity. I think it's a really great opportunity John's described about the challenges of doing this sort of work quicker and more effectively. But I think as well, not just on the project value and the money, but also it's great to see John highlight, you know, rehabilitation cost in particular. And I think it's a great opportunity for the group today.
Okay, excellent. So let's kick off with our first METS company. It's Gerald Whittle from Whittle Consulting. Gerald, you've got 3 minutes and a few slides to show us.
Thank you. If you could put the first slide up. Thanks. So Whittle Consulting is a relatively small private consultancy based in Melbourne, but operating worldwide. We've been in business now for 20 years. Our subject is integrated strategic planning, specifically for mining. Next slide, please. So it is, what is integrated strategic planning? It's a cross-functional collaborative process that involves all parts of the value chain, all time periods, and ultimately considering all stakeholders. We do focus heavily on financial returns for our shareholders. Next slide, please. The approach is to build a single model of the whole system. So from the block model through mining systems, through the plant systems, logistics, commercial model, financial model. There's a lot of data, even in a pre-feasibility study, let alone in an existing operation, but it tends to be managed in 6 different software systems managed by 6 different organisational silos. We use activity-based costing to get a much more detailed valuation of the blocks in terms of the cost of mining, processing and producing from them. We therefore have a dollar version of the block model. We use theory of constraints to identify the bottleneck in the system, and we redo the whole life of mine plan, whether it's pits, underground, all through the processing flexibilities, product flexibilities, and capital scaling if necessary on a dollars per bottleneck unit basis. Quick example might be an open pit where the mill powers the bottleneck in a system. We're doing pit phase, schedule, cut-off, etc., grind size, mass pulls to concentrate on a dollars per bottleneck unit, which would be dollars per kilowatt hour of the bond work index. Next slide, please. The objective is primarily MPV, bring the cash flow forward. Here are 4 examples. Our track record, having done about 200 of these studies, is between 5 and 35% increase in MPV or substantially more. Next slide. So how is this relevant to the investment thesis? Our approach on this slide is generally starting in the top left-hand corner, get everybody involved on the team through the 2-day seminar that we run, and I think many of you have been on that. We've got to align our thinking terminology. At the bottom left, this is the important opportunity for investment decisions. A strategic assessment is a relatively short piece of work, maybe over a week or 2. We're not going to build one of these models in that time. It's not possible. But having done 200 of these exercises, we have a pretty good idea what to look for. This could be part of due diligence, could be part of an investment analysis, could be done on behalf of the seller to make sure they're presenting the maximum value for their property, or on behalf of the potential investor, looking at an opportunity and see what value has not yet been identified by the existing management. The full enterprise optimisation study, that's 3 or 4 months work. That's rewriting the whole life of mine plan. That comes later. But whether we're the preliminary process of getting mental alignment and doing a strategic assessment, I think is that very realistically that 4-week process. See what value's there from a strategic point of view. I don't have any comments particularly on rehabilitation and closure costs. This is more looking at the whole picture from the go forward. So cut off, not just cut off, grind size, product specification, pit optimisation, underground, all integrated, and form a view on that early, see what the upside is, and quantify that within a broad range.
Thanks, Gerald. Colin, did you have some questions for Gerald?
Yep. Yeah, thanks, Sherene. Thanks, Gerald. I guess a couple of questions. I've got first one, you mentioned you create a single model, and I know I often battle with the fact in the DD work we do, there's never a single model, not often. So you put that together in your strategic planning process, and you mentioned you use activity-based costing and theory of constraints. So how do those sort of tools really assist you to get that single model and identify the best value out of the project?
Well, the single model, that takes some special software. We have the Probery software, and just to be clear, we're not building one of these models in a strategic assessment, but we would in a full enterprise optimization study. It's very sophisticated software. We end up with one model from the block models, the blocks, individual blocks, through to the discounted cash flow and the financial model in one model. The activity-based costing and so forth is a more accurate way of applying the cost to the different blocks. There's a lot of averaging, smoothing, testing and application of settings on composites. We don't need to be limited to those sort of rules of broad brush approach anymore. We've got the computing, we've got the data these days. We should be using it. So we're looking for variation in the ore body, not just in grade, but in bond work index, density, hardness, abrasiveness, whatever drives the value, and exploiting that variation.
Okay, thanks. I guess another quick question. John mentioned in his opening around, the use of cut-off grade as, say, the best way, or a way to, a knob that is often turned in projects to create more value or erode value. What other sort of things do you think are good to use to understand the best value, and how do you identify them? And I know you mentioned a couple in your preso then.
Right, so cut-off is one of 10 mechanisms we use. It's a very important one, a very misunderstood one as well. The right cut-off grade will be a dynamic cut-off grade over the life of the mine, as per Ken Lane, be different for different material types and different depending on where the bottleneck is in the system at that particular point of time in the life of mine. Very deep subject. But equally, we get similar uplift from optimising, say, the grind size in a mill. And not every mine has a mill, but mines that do have a mill, this is often the primary bottleneck. It's just as important as the grade. It affects the grind, the grind size affects the throughput, the recovery, often the product quality as well. There is more and more data available on that is not getting used currently in mine planning or planning for a mining business. And I'd see if you had to rank them, cut-off grade and grind size would be the next on the list, but there are several others as well.
Thanks for that, Gerald. Colin, we might move on to our next speaker, Andy Mulholland from Dassault.
Thank you, Sherene and Colin, and thank you, John, for the opportunity to present to IMARC. I wanted to start by just looking at who we are at Dassault Systèmes. At DS, everything that we do in all of the industry segments that we operate in is underpinned by this one core belief that you see here, and that is that by simulating in the virtual world, we can create or we can make the real world a better place. What this means in a mining context and what this means for EMR Capital is that by creating a virtual twin of the mine, we can optimize and simulate many possible outcomes and hand you the levers to select the right design, the right scale of production, and the right risk to meet your investment profile. On the next slide. So why Dassault Systèmes? Well, we are one of the leaders in strategic mine planning in this space, in this technology space. Our Geovia mine planning portfolio has been a benchmark in the industry for many years. The Geovia Whittle software is synonymous with open pit optimisation, and we actually acquired that from Gerald's father, Jeff, some years back. The Geovia Serpac part of our portfolio is where our strategic optimisation solution for underground sits, amongst a number of other solutions that we have. And Geovia PCBC is used by just about every caving operation around the world for life of mine. On the next slide, so that's not all. That's part of what we provide. Our next generation solution that we have now is centered on 3D Experience, which is our collaborative business and engineering platform used in 11 different industries by more than 250,000 customers around the world. The same technology that brought the Dreamliner to Boeing is used and underpins this new solution that we have here for strategic mine planning. So what we can do for EMR Capital is provide you those industry-leading tools I mentioned before, plus the ability to do multi-physics simulation that can help de-risk the mine plan and think geotechnical analysis and geotechnical simulation there. And we can provide option simulation capabilities, which is probably one of the most important things in the space that you're looking at, John, in terms of running many scenarios in that 4-week period of project evaluation. So in option simulation, we can run the whole strategic planning process many thousands of times to look at all of the possible scenarios to make sure that you can select a plan that's robust. And lastly, in the portfolio, we have governance capabilities through 3D Experience platform, so you can capitalize the knowledge and the know-how that you've built in each project for the next project that you invest in. So lastly, one of our customers, just as a couple of examples, one of our customers told us if they could increase the pit wall angle by just 1 degree, they would save $1 billion over the life of mine. Now, a geotechnical simulation from our multi-physics portfolio can help validate that that change is actually feasible. For another customer, recently we ran more than 10,000 simulations of the strategic plan, and we uncovered 40% additional MPV, and we detected the production scale that maximised that MPV. So, John, if you need to make investment decisions in a very short time frame and look at various different possible scenarios, varying the input parameters and constraints, then we think we can help.
Right. Thanks, Andy. Colin, you have some questions for Andy?
Yeah, thanks, Andy. That was interesting. I guess probably 2 questions kind of thrown into one, and it was great that you mentioned, the use of this software in other industries like Boeing and the aviation industry. You guys at Dassault are very much focused on innovation and bringing in new solutions and technologies. What sort of things do you have in the pipeline or, working on at the moment to continue to, going back to what John says, identify project value, do it more quicker, more efficiently and across the whole mining stream? And then I guess with that, are these sort of technologies coming out of other industries like, aviation and defence, or, what's next for miners that Dassault's offering?
Good question, Colin. So I guess some of the technologies that we're bringing into mining that you see in this solution right here is the ability to run many, many scenarios. And this is technology that's been, like I said before, has been used in the aviation industry to find the right balance of design, strength, weight, all of those parameters for an aircraft frame. And the use of that technology by Boeing has helped bring that the 787 Dreamliner to life. Very revolutionary aircraft. The other parts of the Dassault Systèmes portfolio, from a multi-physics simulation, we have recently used our geotechnical simulation software and also our flow simulation software to model the Brumadinho Dam failure and what happens to the tailings as that tailings flows down through the downstream river system and valleys and so on. So there's flow simulation software, that sort of thing. When you look at downstream in the manufacturing space, so production operations in a mining context, the manufacturing operations and manufacturing execution systems that are used by most of the automotive manufacturers around the world from Dassault Systèmes is something else that we're also looking to bring into mining. We have started bringing into mining.
Thanks, Andy. We might move on to our next speaker, who is Ainsley from Deswik. Ainsley.
Oh, hello, everyone. When talking about the evaluation of the next generation of projects, the cost of mining and the cost of closure are two sides of the same coin. Mine closure regulations are progressively tightening as a systemic response to poor closure outcomes and a gap between expectations and performance of planned reclamation. Many projects in Australia are currently without a fit-for-purpose, designed, scheduled, and fully costed closure plan. During the sales process, miners typically commit to an asset strategy using a high-level closure plan, which may only be at a scoping study level of detail. Executable closure plans are not being generated or critically reviewed until the end of mine life is imminent. When these plans are then assessed in detail, often the closure costs are far greater than what we had previously been estimated and budgeted for, resulting in miners potentially missing the opportunity to mitigate closure risk through comparing and analysing fully integrated and costed closure scenarios. Quantifying closure liabilities through integrated mine closure planning has benefits at all planning stages, but may have its greatest impact on the project evaluation stage. Next slide, please. None of this is easy. Integrating closure planning into project planning can be a quite complex undertaking. There are many interdependencies and iterations that need to happen to produce an optimised result. It can be an overwhelming and intimidating undertaking, but that doesn't mean that it can't be done or that we shouldn't do it. Notice that tools like Deswik are only part of the picture. Without an integrated approach such as this, companies will not unlock the full value or manage their risk. Next slide, please. This is where Deswik can simplify, streamline, and add value when considering an integrated approach. The Deswik suite of tools have always allowed users to produce and animate detailed and costed mining and haulage models to a nominal final landform. With the introduction of the Deswik Enviro landform engineering tools, users can now perform haulage modelling using an operational dump design and then model, schedule, and cost the reshaping to a stable final landform design for closure as part of each design iteration. This allows miners to make informed material placement decisions by assessing the impact of initial dump designs on the final closure landform. The repercussions of committing to an unoptimised final landform can be massive. From closure costing projects that I've worked on, the cost of material movement alone to reshape a waste dump or mining void into an acceptable final landform can make up to 75% of the total closure costs and be well above previously budgeted estimates. Asset strategy and closure liability are the two highest value reasons to start this journey. However, an integrated team and tools will also deliver value from operational efficiencies, study costs, and planning productivity. The integrated mining and closure plans and animations produced by Deswik software are excellent tools to communicate these scenarios to stakeholders, with the ability to incorporate changes to plans quickly and easily. Even though these tools are simple, they are effective in highlighting potential issues early on, resulting in greater project value and improved closure outcomes. When evaluating and optimising projects, Deswik software can be used to obtain a greater understanding of the impacts of different mining strategies on the closure outcomes, resulting in more informed decision-making, which in turn leads to greater project value and reduced closure risk. And that's it. Any questions?
Excellent. Thanks so much, Ainsley. And just so everyone knows, we will send a copy of the slide deck out to everyone because there were obviously some of that information was quite small, so you might not have seen that. Colin, do we have questions for Ainsley?
Yep, thanks Ainsley. I think it was great to have that focus on closure and what you said about it being integrated and all the interdependencies. I think we know it's complicated and a difficult thing. I guess more specifically on the tools that Deswik have, you know, how do we, you know, what are those sort of tools and how are they used to understand that rehabilitation cost? Is it just through the mine scheduling and the haulage analysis? And I guess maybe a bit of a second part to it is, you know, what are the next steps, you know, Deswik's working on in that space around, you know, going to John's challenge around doing it as quick as we can, particularly evaluating projects?
So the first component is the mining and scheduling side of things. So Deswik software does that. We also do landform and haulage modelling. So you can link your mining blocks to dump blocks and do haulage costing through that. The next step with the Deswik Enviro tools is you can take either an as-dumped surface or a planned dump surface and then apply the final landform grades to that. And it will create a balanced cut and fill solids with a resultant final landform surface. And then we can model the reshaping costs through a dozer push modelling tool as well. So, and you can also take those dozer push solids and then incorporate them into your mining schedule as well if you're looking at doing rehab progressively. So it's an extra step. Like a lot of companies, when looking at their mine closure reshape costing, are looking at like a dollars per hectare sort of like valuation instead of actually looking at an actual 3D volume with proper costing associated with it valuation.
Thanks, Ainsley.
Just a quick question, Sherene, if I could.
Yeah, of course.
So, Ainsley, does this come as part of your general suite of products, or is it an add-on?
It's an add-on.
The Enviro tool?
The Enviro tools are an add-on. So we have landform engineering tools, which are the reshape and dozer push modelling, as I mentioned previously. And we also have a water catchment analysis tool as well. So with 3 minutes, I couldn't really talk about, you know, like the added advantage of looking at what your water catchment situation is at each point in your mining sequence and seeing if that produces a whole list of other problems that you need to address.
Thank you.
Thanks, Ainsley. Now we'll move on to, I guess, our next three speakers. The first one is Matt Pyle from Ausenco. Matt.
Thanks for having me here, everyone, and it's good to be in such elite company. I work closely with John on a number of projects, but today I wanted to describe to you how we, I shouldn't have made the title so long with only 3 minutes, but how we can assess the problem that John's asking, which is assessing the value of projects within a 4 to 6 week period by focusing on the process plant. So taking on what Gerald Whittle said, and I subscribe wholeheartedly to his intent there, the goal is to maximise the net cash flow divided by capital cost, because someone's asking John to stick his hand in his pocket for money. So really the return on that capital is the main thing, but it's not always the focus. In this day and age, conventional processing approaches aren't always viable. So head grades are reducing, metallurgy is becoming more complicated, and ESG requirements are increasing. Grade is not value, particularly when you get to the process plant. We're finding more and more that's not the case, although it is counterintuitive. And you know, and this might be a little bit controversial, but from our perspective, getting metal out of the ground is the easy bit. I know there's a lot of challenges around mining, so I don't mean to oversimplify that, but it's certainly not the end of the process. On the right-hand side here, I'm showing broadly the ways you could process ore into final product. And there's actually about 10 rejection steps for the case of copper. So rejecting waste at the mine is 2 of them. There's another 8 that happen after that. And I guess I'm trying to highlight there's an opportunity in making sure that waste is rejected at the right place. So the solution to these problems is to take the approach of mining hill of value, which is to do a number of scenarios quickly, do it at a high level in a 4 to 6 week period, but really flex the options around the process plant and focus how you reject waste in the most economic way possible. Like was mentioned earlier, we need to include the whole process plant, everything from the mine to the product and tailings, including closure. There's a number of ways to reduce closure costs by rejecting waste in more economic ways, whether it be bulk sorting or coarse particle flotation, so new processing technologies, and to challenge the paradigms, do for $1 what any fool can do for 2. And you really flex this to give the best outcome. Next slide, please. In the last 30 seconds, I wanted to give you an example of how it was done wrong and how we changed it. So this year we commissioned a project. The metallurgist focused on the 11 copper types, which are very interesting and look quite pretty, but that's not where the value was. They landed at a complex flow sheet. And long story short, we changed the processing approach, ended up changing the mining approach, reduced the capital from 400 million to 6 million, and they executed the project out of operating budgets. NPV on capital increased by a factor of 70. So that's the sort of step change you can get by looking at the whole process the right way.
Thanks, Matt. Colin, do we have a question for Matt from Ausenco? And obviously, Ausenco provide a little bit of a different perspective to this in this conversation.
Yeah, definitely. It's and thanks for putting those rocks pictures in there, Matt. I think some of our geos online probably enjoyed that.
Yeah.
Just on
I find it interesting too, but it's not where the money lies all necessarily.
All the time. I guess just thinking about it, you definitely, I'm a mere mining engineer, like you know, and I think you raise an important point around the cross-discipline sort of the multidiscipline team approach that's required. How does Ausenco deal with that in assessing a project to make sure, you know, the best outcomes for the project? And, you know, the old stereotypical battle between the metallurgist and the mining engineer, and if the geo's not there, blame them sort of thing. How do you manage that?
Yeah. I mean, historically, I think that approach worked. You could set a mine plan. You could say the operating cost was 10 or 15 bucks a ton, wherever you are in the world at your scale. You could throw a recovery out of 90% and away you go. And you know the costs. It's not really like that anymore. And if you want to make the best value of new projects, you have to look at them differently. So it's about not working in silos, as you say, getting engagement early. Typically, we find mine plans are developed before the studies come into our door, so that early engagement's key. And then really working together to flex what are the different mining options and what does that mean for processing. You know, the approaches that Whittle and Deswik and you guys, Mining Plus, advocate are right, but they need to happen with that processing input as well. But the metallurgists can't go off on interesting things. They need to focus on NPV on capital cost. So.
Thanks, Matt. We'll move on to another Matt, Matt Schneider from Optika Solutions. Just want to point out that Optika, I guess, featured in a IMARC event 2 years ago when they first started out. So it's great to see their progress and have them here in this episode. Thanks, Matt.
Thanks, Geraldine. Hi, everybody. So today what we're going to do is talk to you a bit different. So we have a different paradigm that we're chasing in the technology that we are developing. And that is we're actually using artificial intelligence in order to generate simulations of outcomes. So the paradigm that we're chasing to solve is the fact that data is inherently dumb, and it's actually the algorithms that we can apply. So the work that we've been doing is very much around using artificial intelligence in order to develop those algorithms to simulate outcomes and then accelerate it. Next slide, please. So what we've done, our paradigm has been one of how do we create a framework to gather data and accelerate that data capture. So certainly the work that we've been doing in the banking industries as part of asset lifecycle management, investment decisions, have been very much being able to accelerate the ability to go through data rooms, capture the information in a single strategic manner, and then being able to use AI to interpret that and build out models. Next slide, please. Now, what's really interesting is AI is a great tool, but it's actually the ability to create collaborative decision making. And so one of the things that we've realized on the journey has been that we can use artificial intelligence to run scenarios and to test different outcomes. But also we need to be able to ingest large data sets, Excel spreadsheets, and all sorts of other pieces of data coming out of some Deswik tools, etc. And so what we're now looking at is the ability to create these ecosystems. And what's really exciting is through the use of AI, we're now able to deploy these things very quickly. And certainly within 2 to 3 weeks, we're able to create decision outcomes. And what's fascinating is we now run simulations that we can test different structures. So for example, number of stockpiles, locations, etc. And we're able to now synthetically create almost like the virtual worlds to come up with the most optimal outcomes. And for example, for one of our clients, we were able to reduce their capex by about $700 million to $1 billion, align it to the market, etc. So all of these things now becoming really possible, and it's a lightweight approach, and it's quite different to some other techniques out there. It's still new, but it's pretty exciting where it's heading. Next slide. The other thing, obviously, is always about telling the story of data. And here's some examples. At the end of the day, it's how do you communicate the insight that you have, and being able to tell it via a very pretty picture. You can use augmented reality in VR, but interestingly, what we're finding is the ability to just simply determine, is it a viable one, yes or no, highlighting where the issues might be within the value chain for the mining asset that you're evaluating. So that pretty much provides a really quick summary. Any questions?
Thanks, Matt. Colin, do you have a question for Matt? I've got one from an attendee as well.
Maybe fire that one away, Sherene, if you want.
Yeah, I will. So Felix from Newmont has submitted a question here. And I guess this is a bit of a challenge, but obviously understanding there's an emerging AI tools in mining project evaluation. Do you think these are likely to replace the current tools or complement them, Matt?
I think in the next 3 to 5 years, I think they'll be complementary. I think longer term they will replace. I appreciate that's in a fairly aggressive stance, but certainly some of the stuff that we're dealing with has just been mind-blowing. So for example, we're now able to simulate processing plants, improve them dramatically. We're looking at sentiment analysis, the ability to do data provenance, all that sort of stuff's coming online. And so I think, what I'm hoping within the ecosystem, these companies have got massive, fantastic pedigrees will actually use these tools, use these new techniques, and I think it will be taking the entire industry forward. And ultimately, it will enable us to mine in a safer, better way, and more environmentally friendly and a more sustainable way. And I think all of that will be fantastic for our industry as we move forward.
Colin, did you have a question for Matt?
Yeah, Matt, I guess in this sort of space, a term that's getting thrown a lot around is, data analytics as a service. How do you see that being picked up in the mining industry and particularly around evaluating projects? Is it, you find the industry's now pulling your services through and it's easily understood, or still a challenge?
I still think it's a challenge. So I mean, we have, we as an industry, we struggle with new tech and innovation. What I find fascinating is the ability to bring lots of these data sets together. But unfortunately, it's very difficult to understand the decisions that these things can support you on. And certainly, the concept that you can do a measure while drilling, tying that into a geomet model, and then tying that into your market or into a customer profile in a mill or a smelter. 20 years ago, they were like pipe dreams, but they were doable now. I think fundamentally, though, the industry is still a long way to go. I saw a stat the other day where mining spends about $6.3 billion of innovation, whereas tech companies spend about $400 billion. I think there's a reason why they're trillion-dollar companies and we're still in the hundreds of billions for the big boys. So I think we have a long way to go, and hopefully we'll be able to embrace that journey.
Thanks, Matt.
Thanks, Matt.
We'll move on to our final speaker, also another Matt, Matthew Nichol from REMPLAN, who actually was invited to be part of this by the Victorian Government as their regional Bendigo solution provider. Thanks, Matthew.
Thank you very much, Sherene, also to John and Colin and all of the other speakers. So I'm an economist with REMPLAN. I work alongside software developers, land use planners, and consultants. Elaine, next slide, please. Look, it's been really interesting hearing the other presentations, and I can see how a lot of these solutions relate to some of the work that we do. One of the core software products we develop allow economic impact analysis of scenarios. So these could include capital expenditure phases for projects, the operational phase, rehabilitation. An operational phase might look at the level of operations a year out, 3 years out, 5 years out. And the type of analysis that we're generating are direct and supply chain impacts for jobs, economic output, gross regional product, exports, all of these economic measures. It's all region specific. So in a Victorian context, we might be looking at somewhere like, say, Horsham Rural City. I don't know, it might be a mineral sands project. You then might look at the broader implications for the wider Wimmera region, and then zoom out to the state level and look at the state level implications. So this software and data ecosystem that we've built, it's region specific. We keep everyone up to date. It's consistent over time. So we've been doing this for about 20 years. It's consistent all across regions. So whether you're looking data for, say, East Pilbara Shire or East Gippsland in Victoria, you can compare all of that data on a completely like-with-like basis. So we build and maintain these economic and also demographic data sets for Australia, all the states, all the regions, all the local government areas. In relation to, I guess, the problem that was presented by John and EMR Capital, I think this is a really critical point. We build these data sets in advance to anticipate demand. So we can build, very bespoke things on demand as well, but we actually have these data sets built and ready to go. So if somebody needs the data, we can potentially have them up and running in the same day. They're able to run these scenarios. Elaine, next slide, please. So the way that we support mining companies is, look, it's usually in the context of economic impact reports, business case preparation, EES, stakeholder engagements, and so it's this application of the software and our tools, and it's so it's via socioeconomic impact modelling, cost-benefit analysis, infrastructure services impact modelling. A lot of our government clients, there might be a mine proposal in their region, certain mixes of local resident workers fly in, fly out, a certain number of heavy vehicle movements per day, and and thereafter advice on perhaps the impacts on the road network and the costs associated with that. So it's an input into perhaps their discussions and negotiations with government, with the mining companies around community contributions. Our clients, you can see some of them listed there for the state government agencies such as DJPR and DELP, New South Wales Treasury, various consulting firms. We work directly with mining companies, but a lot of our engagement is indirect via the other organisations we work with. So there's a consulting arm to our business, but then we're also working with companies like GHD, PwC and EY, who then use our tools, use our software and data to support the mining industry. We've also done quite a bit of work, in particular for the South Australian government, actually looking at the value of the met sector for that state's economy as well. So thank you very much.
Thanks, Matthew. Colin, do you have a question for Matthew?
Yeah, thanks, Matt. That's definitely an important part of the whole mining and met sector. That's probably maybe understated at times what we contribute. So thanks for sharing. I guess in that approach, do you get involved in identifying any specific risks around a project across the whole, ESG, ESC area? And, what are the sort of things you see and how you assist with that?
Well, certainly, if you, So often with an EES, you know, that we might need to address questions around the implications for population, housing, access to workforce with the requisite skills, particularly when we're looking at one project in the context of other proposals, other mining projects that are in the pipeline, and they're often looking at the aggregated compounding implications of, you know, multiple projects happening over the same time frame.
Okay, excellent. I've got some questions here actually from some of the attendees. If we can, if it's okay that I ask these. We have a general question which might actually be for John as well. Is how important is it to have more than one independent assessment of value done in the 4 to 6 week period? Is it just a matter of cost or individual assessment?
Yeah, I think, I suppose it's hard to say there's always, you know, there's only one case, and it's, you know, it's probably dangerous to say we're putting all our eggs in one basket. I think what we try and do is, you know, get a base case, but then have variations on that theme. So what are your downside risks? And if they played out, what would be the economic impact? And how would you cope with that from a, you know, operational point of view, but also from a financial point of view? Okay. But also we don't want to lose sight of, you know, what is the upside potential if this plays out. You know, if an ore body proves up, what could it become? So in terms of, I suppose in the end, you've only got enough time to go to so many groups. I think you've got to work with quite a tight group, because you can't, you know, we find you can't be a scattergun approach. I suppose you've got to have some conviction with how it will play out, but make sure you understand both the upside and the downside.
Thanks, John. We've got a question from Andy Reynolds here about what would the presenters like to see done differently in how PEAs and feasibility studies are conducted. Any comments on that around feasibility studies and PEAs?
Perhaps I can comment on that. I think the biggest opportunity is this cross-functional collaboration. This is still a very linear process that the mining industry tends to go through, working in silos, and it's missing opportunity left, right and centre. It is more complicated to work together. You need a framework for that. But it's still very, you know, the engineering approach to a complex problem is to break it up into components. That's fine. You need specialists, but putting it back together is the biggest opportunity that we see.
Anyone else have a comment on that?
I wouldn't mind adding something to that, Sherene.
Yeah.
I guess around that too is, I think in this whole space, if I understand that question around PEAs and fee studies, is, you know, the PEAs is often, it feels like you know, particularly with the reporting codes around the world, the inconsistencies, and at times you spend more time actually writing a long-winded report that no one reads, particularly for 43101, without actually really realising the value from the project, and spending the time on that good discussion like Gerald just describes, and sitting there writing these very long reports, and that can be very frustrating. And around fee studies, it's probably also the inconsistencies and expectations, because there's really no real guidelines on how to do them for the different requirements. It's just do a fee study, but that means so many different things to so many different people.
Maybe I'll just add one more thing to that. It really comes down to the question you're asking. The early concept study levels, there should be about casting the net on the potential options and answering the question that you posed, John. What could it look like in 3 to 5 years? PEA takes a slightly different view of that and says, well, what is an economic case for it based on a more standard processing approach? And a feasibility study, hopefully by then, has converged on the most viable base case and is trying to flesh out the detail. I think the focus which can add most value is making sure that the net is cast with the right people, as you said, Gerald, you know, at the right time with the right integration to sort of make sure you don't leave an option on the table.
Got another question. Oh, sorry.
To add to that, I think seeing the stuff that we've done, bringing a whole pile of thought leaders together and then being able to rattle through it in a really collaborative way, particularly if you've government agencies having to work with, etc., is really transformational in in the velocity that you can move at. And I think if you can have an open mind about how we can do effectively an open approach to some of this stuff, I think that'd be pretty exciting.
Thanks, Matt. I've got a question here about, and I'm not sure who to answer this, but how's the concept of value measured against intangibles when making bottom line decisions? Anyone want to have a...
Yeah, I think that goes back to the pitfalls, Sherene. The intangibles are, it's trying to understand, well, what could happen? What if, I suppose the regulator didn't like the tailings storage facility that you put up, or the closure plan, or whatever. So ensuring you understand the potential pitfalls and understand, well, if you had to do that a different way, how would you cope with it? What if the community didn't like your plan and you had to adjust that? So I think you've got to look at all of those things and say, well, what if, and if it happened, how would I cope with it? And could that destroy value? And I suppose, if you look at projects in, say, South America, water becomes a huge issue in Chile. And you do have to look at that. What if I can't keep using one water source and I have to go to another? And that potentially could be that type of red flag event where you say, well, I'm not actually prepared to take that risk. So it's sort of it's intangibles, but it's sort of what potentially of those intangibles could be a red flag event. I think that's how we'd approach it.
Any comment?
I argue that intangibles are tangible. We do it for risks all the time. We say sum of risks times consequences, and we add them up. There's no reason why that can't be done and shouldn't be done for projects including tailing storage and rehabilitation or failures of dams. That you can do the numbers on it. You can assign a cost per tonne if you know your risk profile. So something's better than nothing, I think.
Yeah, I would agree with that as well. Is at the end of the day, you should be able to distill those intangibles down as some quantifiable metric, and then flex all of the possible scenarios around it, what those outcomes are, and then evaluate it. But yeah, at the end of the day, I agree with Matt that you should be able to find even an indirect quantifiable constraint or input to be able to be the proxy for that intangible.
I'll probably go the other way, and trying to turn everything into dollars, for example, or tons or ounces, I think is problematic. And I think a multi-criteria evaluation is the right way to go. And you've got to look at the plans and alternative plans from a range of criteria. Clearly, economic is top of the list. That's not the only thing on the list. Social, political, environmental as well. Now, we don't support trying to turn economic impact, safety or health or lifestyle or well-being into dollars. I think you're going down a path that's going to ultimately fail. But a multi-criteria evaluation of plans, and that takes some insight, and some of these things are difficult to quantify. You can often quantify the operational impact of having to go to dry stack tailings, for example, rather than upstream wet tailings. You can put a cost on it, but in terms of a social value for that, I think you're destined to fail if you try and put dollars on that. So you end up with a multi-criteria evaluation of a plan. And not everyone will agree on the balance of those characteristics, of course. We've all got a different focus, but we've found that is the most constructive way to approach it.
Thanks, Gerald. As we come to a wrap up of the episode, I'm going to throw this on to John and Colin. So John, you've obviously heard our 6 METS companies, and obviously thank all of them for taking part in the episode and presenting their solutions, all unique and different in some ways. John, any comments about any particular METS company or any feedback or thoughts that you've got from EMR and what you need and require?
Very good. Yeah, no, thanks, Sherene, and I'd like to thank all the METS companies for their input. I think what it sort of confirmed for me is that all the tools are available and there is solutions to all of the problems. what it probably means is that, you know, very early in that process, when you're looking at a mine or a project, you do have to try and make some, I suppose, call for where the value lies, and then choose the tool that you think best suits, and go hard after that. So it's very difficult, I think, in the 4 to 6 weeks to test, you know, every variable. And as Gerald very rightly put up, that cut-off grade is only one. Sometimes it's going to be grind size, and there's a multitude, you know, there's many variations. So it's making sure when you first look at it, try and understand, you know, what are the things that could impact value here, and then go and choose that tool from, you know, whichever of the METS companies, and engage very quickly and go as hard as you can.
Is there any particular METS company today, John, that you would say was a standout for you, or something that you learned something different from?
We love them all, and we work with many of them, and you know, we'll continue to do so. I mean, it was great to hear from, you know, from Deswik that I wasn't aware of that environmental tool. Now, we used a lot of their software underground, but it's thinking about, okay, how we could get the integration going, and also from the other groups, you know, a lot of that software, whether it's Gerald's or Andy's, or, you know, Matt's approach, we're using that, you know, often once we're in there. It's our ability to get that up the front, and really and work with each of them to think about how can we be more creative in the initial phase.
Okay, thanks, John. Colin, any departing words from you as we wrap up the episode?
Firstly, just thanks to everyone for participating. I think it was a great suite of different presentations and people here, and also thanks, John, for participating as our miner. I think it was a great opportunity statement he put forward. Standouts for me would be, it was great to have that whole range from, you know, thinking about mine designs, the whole interactive approach, and, you know, Matt from Ausenco more with the processing plant, and obviously as well the environment and the whole community aspects. I think was great. But a thing that stood out to me was sometimes we think of the technology as the silver bullet, but it's clearly not. I think everyone has mentioned it's about people getting together, collaborating and asking the right questions and using the information to make good decisions. And I think that's an important thing, that everyone provides a good solution, but it still relies on the people getting together, talking and collaborating.
Thanks, Colin. So again, thanks to all of our METS companies, Gerald, Matt, Ainsley and Andy for taking part. John, again, thank you so much for being our guest speaker. This has been recorded, so we will share a copy of this episode around, as will the PowerPoint presentations. As I said, you'll be able to see that in a lot more detail. And if anyone wants to connect with any of our MET speakers, they'll be able to do so as well, and let us know if you would like to get hold of these guys. Thanks again, and we look forward to next month's episode, which will feature a miner from Codelco talking specifically about digital transformation challenges that they face over there in Chile, and a bunch of METS companies that are involved in that conversation. If anyone wants to know more about IMARC online, then also reach out to me. But I look forward to hearing from you all soon, and thanks again. Thanks, Colin.